Okay, so for graphing inequalities, let's fill up this outer portion. So only if it helps you, I'm going to write these on my paper. You don't have to, but if you want a reminder, let's just write how we would say these inequalities. So this first one, how do we say this one? Greater than or equal to. So if you need that reminder, just write it next to it. Greater than or equal to. So remember that little line underneath is also, it's kind of like half of an equal sign. So it's greater than or equal to. So for inequalities, you need to know how to graph a line. That's why I did it as a bell ringer to kind of refresh your memory. So you need to know how to graph the line. The only difference is then we're going to shade one side of the line, because when we have an inequality, it's a set of solutions. There's more than just one solution. So we have to shade the whole solution region. So if it's greater than or equal to, think about how if we drew a line through this symbol, it'd be pointing to the right. So we would shade to the right of the line, or in this case, we also think of it about it as above the line. So you're going to shade above the line. And then if the inequality has that extra line underneath it for or equal to, we want to make it a solid line. So put solid. So you're shading above and it's solid, because that means everything, all these ordered pairs on the line are also included because it's or equal to. All right, then going over here, how do we say this symbol? Just greater than. So notice how this line's different. Now it's a dashed, or you could write dotted, whatever wording you like. I'm going to put dashed. So it's a dashed or dotted line because it's just greater than. It doesn't have that or equal to, so none of the points on the line are part of the solution. So you would shade above still, above the line, and then dashed or dotted line. And then what would be this symbol? Less than or equal to. So again, it has the extra line underneath it. One of my students once said, like, there's more ink on the symbol, so that means you would put more ink on the line and make it solid. I thought it was a good way to remember it. So when you see that extra line, solid. We want to put more ink on the line. And so this we would shade, and then if it's less than, we're shading below the line. All the numbers below it are less than. So shade below the line, and it's a solid line. And then how would we say this symbol? Less than. So again, we don't have that extra or equal to, so it's a dashed or dotted line, less ink. So again, less than, we shade below the line, dashed line. All right, let's start. So this is just like showing you all the symbols and stuff. Each inside doesn't necessarily correlate. It doesn't mean the equation's going to have the same symbol. So just know, like, the inside doesn't necessarily correlate with what's on the outer part of the flap. Just goes over different examples. So the top two are linear inequalities in two variables. So let's start with over here, the steps. So first you would solve the equation for y, just like we've been doing when we have an equal sign. We're going to solve it into like slope-intercept form. And then you're going to graph the y equals line. So again, we're just graphing it just like we would an equation, but then we're going to either make it a solid or dashed line according to whatever the inequality is. And then we would shade above or below the line. So again, an inequality has more than one solution, so the shaded region is all of the solutions for that inequality. So let's say we have, for the example, 5x minus 3y is less than negative 15. So again, just like the bell ringer, we need to isolate y. So how would we go about that? What would be the first step? Subtract 5x. So yeah, if your x term is on the same side as y, we want to move it to the opposite side. So minus 5x from both sides. Then we cancel those out. All right, then we would rewrite it, negative 3y is less than, again, it doesn't matter, you can put negative 15 minus 5x, but I like to put negative 5x minus 15. So don't ever combine those. One has a variable and one doesn't, so we have to keep them separate. All right, then we want to isolate that y, so how do we get rid of that negative 3? Divide everything by negative 3. Do you remember what happens when we divide by a negative? The sign flips. So y is greater than, and then again, keep your slope in simplest fraction form. So if it's negative 5 divided by negative 3, it would become positive 5/3 x. And then what's negative 15 divided by negative 3? Plus 5. All right, so put a box around that. That's our final answer. And then we just have to graph it. And then to graph it, we first would mark our y-intercept. Where's our y-intercept? What's the ordered pair? 0, 5. So 0, 5. So on the graph, put a point at 0, 5. And then what's our rise over run? 5/3. So from that point, you would go up 5 and then right 3. You really only need those 2 points, but sometimes I just like to make sure my line is as accurate as possible. So if you don't have any space to go up, then go the opposite from the y-intercept. You would go down 5 and then left 3. And then once you have 2 or more points, before you draw your line though, let's go back to inequality. It's y is greater than. Would that be solid or dashed? Dashed. Remember, it doesn't have that extra line under it, so it's less ink, if that helps you remember it. So dashed or dotted, however you want to say it. So just kind of pick up your pencil or your pen as you're drawing your line to make it dashed like that. I would recommend using pencil when you do the practice because these are easy to make mistakes at first, and I had a lot of students in first block getting frustrated because they were doing it in pen and stuff. Even before you shade it with your highlighter. So I like to shade it with my highlighter. You don't have to. You could just shade it with your pencil, but to me it just looks cleaner and neater with the highlighter. So if you want to just use your pencil, that's fine. But which side would we shade? If it's y is greater than, is it going to be above or below? Above. So if you use your pencil, that's fine. Just make sure you're shading that whole region. To me, it just goes by faster with a highlighter. And it looks nicer. So it means every single ordered pair in that shaded region and above, because remember, we only see like a little snapshot of the graph. But all the ordered pairs above this line, they're all solutions to this inequality. All right, next example on the right. Negative 9x plus 3y is less than or equal to 3. What would we do first? We want to keep the 3y there. Yeah, so again, move your x term. So if it's already negative, we're going to add 9x to both sides. 3y is less than or equal to, and then just rewrite 9x plus 3. And then what do we do to isolate the y? Divide by 3. Y is less than or equal to 3x plus 1. Only if we divide by a negative. We divided by positive 3, so it stays the same. Yeah, so only flip your sign if you divide or multiply by a negative. All right, and then what's our y-intercept? 0, 1. So put a point there. And then what's our slope? 3. And then I always like to write it as a fraction so I know my rise overrun. So if it's just 3, what? 3 over 1. So remember, whole numbers are always over 1. All right, so then our rise would be 3, so we would go up 3 and then right 1. Would it be a dashed or solid line? Solid. Remember, we have that extra ink, that extra line. So the line is solid, and which side? Here, let's draw our line, and then let's think about which side we would shade. So if it's y is less than or equal to, are we shading above or below? Below. And then let's test a point just to make sure. So what's one ordered pair that's in this shaded region?
1/4.
So yeah, 1/4 is right on the line. As long as it's a solid line, that would be a solution. So we could test. So if you have room, write this with me. If not, just pay attention. So let's test the point 1/4. So if it's on the line, it's only a solution if it's a solid line. Just a reminder. Okay, so when you're testing it, go back to the original equation, negative 9x, or original inequality, negative 9x plus 3y is less than or equal to 3, and test out these. So remember, 1 is your x value, 4 is your y value, so we would just substitute into the original inequality. So we would do negative 9, and then for x, parentheses 1, plus 3 parentheses 4 is less than or equal to 3. And then remember, we want it to be a true statement just to make sure you're shading it. So I might even do this before you shade it, just so you know that you're shading the right side. And then solve it. What is negative 9 times 1? And what's 3 times 4? Plus 12. And then what is negative 9 plus 12? Is 3 less than or equal to 3? Yes. So that is a true statement. It means, now that's on the line, so that can help you decide if it's solid or dashed. You would still want to test a point in the shaded region to make sure. So here, I'm going to do it underneath the graph. What would be an ordered pair where it's shaded, not on the line? 2, 1. So here I'm going to test it underneath the graph. So 2, 1, so we would do -9 times 2 plus 3 times 1 is less than or equal to 3. What's -9 times 2? -18, and 3 times 1 plus 3. What's -18 plus 3? Is -15 less than or equal to 3? Yes. So yeah, that's a great way to do it. Test a point on the line to make sure it's solid. So if it's not supposed to be solid, the point on the line would not be a true statement. And then I would check 1 or 2 places to make sure you shaded the right side. Or the correct side. All right, now the 2 at the bottom are linear inequalities in one variable. So these are kind of like what was asked earlier where I was drawing it on the board, where when you see, so like for example, you could also have a vertical line. So remember, vertical is going to be like straight up and down like that. So that's when you just see the x, like x is greater than 2, let's say. So like we were talking about earlier, don't get confused. Yes, the x-axis is horizontal, but when we are looking at an equation or inequality, that's going to be a vertical line. So it's going to be kind of like the opposite of the actual axis on the graph. So if we have x is greater than 2, then we want to go to the x-intercept, which is 2, 0. So we would put a point at 2, 0. And then if it's just the greater than symbol, is that solid or dashed? Dashed. So the line is dashed. So again, go the opposite of what the actual x-axis direction is. So we would go vertically dashed, straight up and down. And if x is greater than 2, is it shaded to the right or to the left? To the right. All right, last example. All right, then, so that was like a vertical line. So you could also have a horizontal line. So that's going that direction. That is not very straight, but you get the gist. So that's when you have the y. So like y is less than or equal to 6. So again, think opposite direction of the actual y-axis, because we need to show all the points that have a y value of 6. So that would go horizontally. So this one, you just need the y-intercept, 0, 6. And then we go horizontally. Would it be shaded or dashed? Or sorry, solid or dashed? Solid. So the line is solid. And then if it's less than or equal to, is it above or below? Below.